Okay, we begin section 2.3, division of polynomials and the remainder and factor theorems. And all this is tied together. Division of polynomials. We talked about adding and subtracting polynomials much earlier. We even did some multiplication. Remember the FOIL and multiplying binomials times trinomials and all that. But we didn't really spend any time thinking about division other than dividing polynomials by a monomial. But what we're going to do is we're going to look at what happens when we divide by polynomials that have two or more terms. And there are two approaches. One works all the time and the other one works only if your divisor is in a certain form. The first method that we're going to look at is just traditional, we just call it long division, and it looks a little bit like long division that you learned back in grade school with numbers. And I'm going to work some examples out and I'm going to try to show you the different themes to kind of keep an eye out for, but I'm guessing this is mostly review. Alright, so long division. I have an example that says use long division, divide 4x to the third minus 23x plus 3 by 2x minus 5. Now one of the first things you want is you want both the dividend, that's what you're dividing into, and the divisor to be in descending order, from highest degree to lowest degree, and both of them are. Also, you want every term shown. What I mean by that, I have an x to the third here, I have an x to the first, I have a constant term. I do not have an x squared term. So I'm going to put a placeholder in for x squared. Over here I have x and then I have the constant, that one's fine. And I am going to set up a traditional long division. This is going to go under here, under the house, and this is going to go on the outside of the house, so out here at 2x minus 5. Now note what I'm going to do right here. I'm going to write this out as 4x to the third, but I'm going to put plus 0x squared as a placeholder, minus 23x plus 3. As you're going through these steps, you want like terms to line up. This will help with that. Now, here's how we approach it. Since we really don't think of dividing a monomial into another monomial, we think of it more or less, what would we multiply times this to get this? If we look at the first terms. And to multiply times 2x to get 4x to the third, I would need 2x squared. So I'm going to put the 2x squared right here. Notice how I line up my like terms. And then once I have figured out what how many times it divides into it, I'm going to multiply times the divisor, stack underneath, and subtract, just like good old long division. 2x to the second times 2x is 4x to the third. 2x to the second times minus 5x is minus 10x to the second. See how my like terms are lined up? And I'm going to subtract. Now, you have to be kind of careful when you're subtracting, and especially if you're subtracting negatives. So my suggestion is this line right here that you just got from multiplying, think of it as adding the opposite. Rather than subtracting this, we're going to add the opposite of this. So to do that, I'm going to change the signs. I'm going to change the sign on the first term, I'm going to change the sign on the second term. See what I've done? And then instead of subtracting negatives, I'm just adding. These cancel out. That's the whole reason why 2x squared is there, because we would get those to be exactly the same, and so when we subtract we would get 0, and then we're not going to put a 0 down. And then here I'm adding 10x squared to 0, and that's 10x squared. Now you remember in your long division, once you subtracted, or added the opposite, you bring down. So I bring down two terms here. I bring down one more term. I bring down a minus 23x. Comes straight down from there. And I repeat this process. What times 2x is giving me 10x squared? Well, that would be 5x, positive. So I'm going to put a plus for positive 5x. Notice again, I'm lining up my like terms. Then I take the 5x, I ignore this term for now, I'm going to take the 5x, multiply, and stack underneath. 5x times 2x is 10x squared. 5x times a minus 5 is a minus 25x. And here again is where I would change the subtraction to adding the opposite, so this becomes a negative and this becomes a plus. That was kind of convenient. You add 10x squared and negative 10x squared, that's 0. You add a minus 23x, which is like a negative 23x, and a plus 25x, which is like a positive 25x, and I get a positive 2x. And I still have to go one extra step. I bring down the plus 3. And one more time. What times 2x is going to give me 2x? Well, that would be a positive 1, because 1 times 2x is 2x. So 1 times 2x is 2x. 1 times minus 5 is minus 5. And here again, I'm going to subtract by adding the opposite, so this becomes negative here and plus here. That's convenient that it worked that way for all three. And I combine by adding, and I get a positive 8. Now remember, this is the remainder. Now there are some algebra books that actually have you put a comma, and then a capital R, and then an 8 as the remainder. And I understand what that means. It's not necessarily the best way to write it out. This is my quotient, this is my remainder. I write my remainder with the quotient by, it's a positive 8, by putting plus, and then I put the remainder all over the divisor. 2x minus 5. Now, there is a way to check it. I'm not going to do the check. But if you multiply this times your answer here, your quotient, including the remainder, you should get right back to the dividend. And that'd be a good way to check your answer. Alright? There's a lot of work here. And you have to be careful. One sign can mess up the whole thing. Let's go over to this example. In this example, I have a much longer polynomial, and it is not in descending order, but it has all my terms. It has x to the fourth, x to the third, x to the second, x to the first, and constant. Now my divisor does not have all of its terms. It has an x squared term, it has a constant term, it doesn't have an x. So when I set this up, I got to make two adjustments. I'm going to rewrite this in descending order. So he goes first, 2x to the fourth minus 3x to the third plus 5x squared minus 7x and a plus 1 for the positive 1. Out here I'm going to write x squared plus 0x plus 3. Again, I need that placeholder to keep my terms lined up, my like terms lined up, and I start the same process that I did on this example. What times x squared gives me 2x to the fourth? Well, that would be 2x squared. So I'm going to put the 2x squared here, lining up my like terms, and then I multiply, stack underneath, and subtract and all that. 2x squared times x squared is 2x to the fourth. 2x squared times 0x would be 0x to the third, it's a 0. And then 2x squared times a plus 3, that's going to be a plus 6x squared. And I'm ready to subtract. But again, I don't like to subtract, I'd rather add the opposite. So this becomes negative, although it's 0, and this becomes negative. 0, this is going to give me negative 3x to the third, and this is going to give me a minus, because I have a plus 5 and a minus 6, a minus 1 x squared. I'm just going to write minus x squared. I bring down the next term, start this all over again. What times x squared gives me negative 3x to the third? I would need a negative 3x. So I'm going to write minus 3x. See how everything's lined up? Multiply through and stack underneath. Minus 3x is a negative 3x. That would give me a negative 3x to the third. And that would be still 0. So I'm just going to write plus 0x squared and a minus 9x. And here again, this is where I change the signs and add straight down because I prefer not to subtract. So this becomes a positive. This, you can think of it as a negative, it's still 0, and then this becomes a positive. Add straight down, these cancel out. I have a minus x squared here because that's just 0, and it looks like a plus 2x. And I bring down the last one. Now I know I continue to divide as long as the degree of what I'm dividing into is equal to or greater than the degree of my divisor. So these are both are degree 2. I continue one more step. What times x squared gives me the opposite of x squared? So that would be a minus 1. Minus 1 times x squared plus 0x minus 3. Change the signs, and then I can add straight down. Again, it's not going to really affect the 0. So these cancel. I have 2x plus 4. Now there's nothing left to bring down, but I know I'm not going to do any more division because this is degree 1 and my divisor is degree 2. So this is my remainder. I'm going to write plus, there's no negatives or anything, plus 2x plus 4, 2x plus 4 all over my divisor, which is x squared plus 3. And this would be my answer right up here. Let me kind of circle that. And over here. All right. Now, one last example here, and it's simpler than the other two for a reason, because once this example is done, I'm going to kind of lead into my next topic by doing the same example a different way, but I'm going to do this one with long division. Hopefully I've left myself enough room. All my polynomials are in descending order, both my dividend and my divisor, and no missing terms, no placeholders necessary. Sometimes you do, sometimes you don't. What times x gives me 3x to the second? Well, that'd be 3x. And I multiply 3x to the second, and that looks like that's going to be a minus 9x. Here's where I change the signs. This is going to be negative, this is going to be positive. I add straight down, I get a negative 5x plus 15. Now, what times x gives me negative 5x? Well, that would be a negative 5. So I put a minus 5 here. That would be negative 5x and plus 15. So now, as you can see, since they're exactly the same, when I change the signs, make that positive, make that negative, and add down, I have a remainder of 0. Which means that x minus 3 is a factor of 3x squared minus 14x plus 15. And another factor would be the quotient there of 3x minus 5. My remainder 0 indicates that's a factor of that polynomial. Now, if we actually factored this down, it would factor into x minus 3, the quantity x minus 3 times the quantity 3x minus 5. Now, the reason I did a simple example is because I wanted to mention the fact that if you have a remainder of 0, it's a factor, and I want to do the same problem again in the next video using what's called synthetic division. Synthetic division is a type of long division. In a way, it's a shortcut. It's when you're dividing by a binomial that's in the form x minus c, where c is some real number. And you can see that's my divisor, x minus c. In this case, c is 3. As long as it's in the form x minus a number, and it could be x plus 5 or x plus 7, it's just that c would be a negative number, a negative 5 or a negative 7. As long as it's in this form, then you can use the synthetic division that I'm going to show in the next video, or hopefully just be refreshing your memory, in the next video to get the same answer, but in a more efficient manner. Now, I will tell you this, we are going to do a lot of division in this chapter, because we're going to be doing a lot of things with finding zeros of polynomials and such, and the better you can do the long division and the synthetic division, which is coming up, it's going to help you. Now, I was never taught synthetic division. I wasn't taught synthetic division in high school, and I wasn't taught it in college, or if I was certainly asleep at the wheel. When I started teaching, I came across it, and I was able to kind of figure out what was going on, and I think back to all the long division, all these steps, and how synthetic division can be done in just a fraction of the amount of work that I had to do here. And I think all the time that I spent doing that, it would have made my work so much more efficient. And again, with long division like this, if you're not careful, if you make a silly mistake with a sign or a product, then it's going to go south in a hurry. So this is really important stuff for you to get down, and we're going to be going over that in the next video.